When you use the sweep feature, there are several options available that will affect the resulting geometry. These options include the use of guide curves, twist, tangency, and orientation. In this lesson, we'll take a look at the use of different orientation types. Although the majority of the time you will likely be using the default orientation known as follow path, it's helpful to understand the effect of using the other orientations. Let's begin by comparing these two individual sweep features. Although they appear quite different, they were actually created using identical profiles and paths. The difference in the resulting geometry is due to the behavior of the profiles as they are swept along their paths. In the first example, the orientation of the circular profile follows the path. As the path transitions from a straight line to a curve, the profile changes orientation to follow. This is the default behavior of a sweep and is referred to as follow path. The second example, you can see that as the path transitions from a straight line to a curve, the profile orientation does not change direction with the path. It maintains the same direction as the original sketch plane of the profile. This behavior is called keep normal constant. To make this clear, take a look at a cross-section view. Notice that at any point along the path, the cross-section is always the same. If I edit this sweep feature, you can see in the options section, there's a list of available orientation and twist types. Currently, the Keep Normal Constant option is selected. If I change this to the default follow path setting and click OK, you see the result is now identical to the first sweep. Once you've experimented a couple of times with the follow path and keep normal constant options, you'll quickly understand the difference between them, and you'll be able to decide rather easily when to use each one. Unfortunately, the same cannot be said about the next available options. For many users, the settings called follow path and first guide curve and follow first and second guide curves simply become something to try if nothing else seems to work. Let me try to explain the idea behind these settings and hopefully make them less mysterious and maybe even useful for you. I'll start with this simple sweep. It's a triangular profile swept along a straight line. I'll edit this sweep. And use this sketch as a guide curve. Notice that although the triangular profile now follows the guide curve, the overall triangular shape is not twisted. That is, the edge that was horizontal to begin with remains horizontal at the end of the sweep. Now let's edit the sweep again, and this time change the orientation to follow path and first guide curve. Now you can see that the profile not only follows the guide curve, but it has twisted. The edge that used to be horizontal no longer is. So why is that? And how is the twist angle defined? Let's edit the sweep once again and change the orientation back to follow path. To help explain this, I have two sketches I'll show, as well as a couple of reference dimensions. The lines I have here connect the path to the guide curve. You can see that in the initial profile, the angle between the line and the horizontal edge is 90 degrees. At the end of the sweep, you see the angle has changed quite a bit. Now let's change the orientation to follow path and first guide curve. Notice the angle at the end face of the sweep is now the same as it was in the beginning. By selecting follow path and first guide curve, you're instructing SOLIDWORKS to twist the profile as it's swept along so this angle stays the same. This may not seem very important to you at the moment, but you would be surprised at how many times users will add guide curve after guide curve in an attempt to end with this exact result, simply because they don't understand how the setting works. If you understand the principle behind the setting, the same thing applies to follow first and second guide curves, except this line is defined by connecting the first guide curve to a second guide curve instead of the path.